Hello, and thank you all for joining us today. My name is Satish. I'm the CEO and co-founder of Connixt, and it is my great pleasure to welcome you all, as well as, more importantly, Roland Cordero, Director of Maintenance and Vehicle Technology at Foothill Transit, a Connixt customer, and super excited to have this conversation with him about maintaining a hybrid fleet and how technology, including Connixt, has been and we'll get to them at the end of this session. Roland, thank you again so much for taking the time today and welcome. And I'm really looking forward to this conversation here.
Thank you very much for the invitation. I really appreciate it. I'm looking forward to the conversation as well. I'm here to kind of provide whatever information I can to all the listeners that's attending this session this morning.
Thank you, Roland. So Roland, before we begin, or right at the beginning, could you tell us a bit about Foothill Transit, what you do there and your specific mandate here at Foothill?
Oh, sure. Foothill Transit is located in the San Gabriel Valley area of Los Angeles County. We're approximately about 35 miles, 40 miles east of downtown LA. We're a joint powers authority where we're governed by the 22 cities in the San Gabriel Valley area. We operate service as far as east to Claremont, which is the easternmost city in the San Gabriel Valley or LA County. We run service up to San Dimas, Glendora. I don't know if people are familiar with the area. As far as Pasadena to the west, and then Baldwin Park, La Puente, Whittier. We also provide a commuter service to downtown LA. A lot of our communities are what we call bedroom communities, and a lot of folks work in downtown. So we provide a commuter service on a regular basis. We have a fleet of 357 buses operated out of two maintenance facilities located in the city of Pomona and one in Arcadia. Out of that 357, we have 33 hydrogen fuel cell buses. That's increasing at this time because we have ordered 19 from New Flyer. So far, out of the 19 buses, we have 8 that's been delivered. So eventually, we'll have about 52 hydrogen fuel cell buses. These 19 will replace CNG buses, old CNG buses that are retiring. We still have 17 battery electric buses, and majority of them not operating because it was built by Proterra. And then we also have two double-deck battery electric buses from Alexander Dennis. In fact, we have also on order 24 double-deck buses with over 700 kilowatts of battery energy. Expect them to be delivered beginning May of next year.
Thanks for the perspective, Roland. And actually, it's a great segue to sort of the next point I wanted to talk about. You've kind of been navigating this transition, from one kind of fleet to another longer than most agencies. Foothill was an early mover on both battery electric vehicles as well as hydrogen fuel cell technology. And you've been outspoken, you've been candid about the battery electric experience and the fact that it didn't go as you would have liked to see it happen. What, if any, were sort of the key lessons from that experience, and how has that sort of shaped your approach to the transition today? I mean, as you manage this now.
That's a good question. So we started our battery electric fleet back in 2010. We had 3 Proterra short-range fast charge buses that only had a range of 36 miles. We operated it on a route that was 16.1 miles long. That's on a round trip mileage. At that time, it only had a range of 35 miles. So in order to be able to operate that fleet in the entire service of the bus in terms of bus routes and blocking. We had to install in-route chargers. That was really quite expensive in terms of building those. We spent about a little bit over $1 million for the in-route chargers. And then we moved on forward to Cordero building 440 kilowatt hour battery packed buses. And we were told that they had a range of 251 miles. But in actual practice, they said nominal miles, 251 nominal miles. What does nominal mean? We found out in actual practice, nominal means you won't meet the 251 miles. It only had a range of 150. So now in order to be able to operate those buses on a specific route that we had planned for those 450 kilowatt buses, we had to install in-route chargers again. Again, the cost of in-route charging is very, very expensive. And you also have to have a separate specific location where to install the in-route chargers. You don't want those chargers out in the street. They have only a clearance of the overhead charge, only clearance of 11 feet 9 inches. So you don't want any commercial trucks damaging them. So it was such a expensive project to implement, to be able to run those buses only in specific routes. And it was very inefficient as well, because in our facility, in our service, we assign buses to other routes. We call them interlining. So you can put a bus on, let's say, Route A. In the middle of the day, that service is done. You can deploy and transition that bus to, let's say, Route B. So you don't have to bring out another extra bus and an extra driver. So that saves you a little bit, saves you in time and cost as well. So originally our plan was we wanted to have 100% battery electric fleet by 2030. Well, we wanted to know how could we realize that plan. So we hired a consulting firm to identify that and write an analysis for us, and that project cost us like $500,000. We found out that battery electric was not a one-to-one replacement because of the range issues. In addition, there were a lot of operational impacts in terms of operating a battery electric bus. For a compressed natural gas bus, you can fuel the bus within 7 to 10 minutes. Battery electric buses takes you hours. So there was a lot of impact in terms of procuring battery electric, and we would have to increase our fleet twofold in order to implement that. We found out that fuel cell buses have the same range as a compressed natural gas bus. Fueling was in terms of minutes, 7 to 10 minutes. So we took a broad step in buying 33 hydrogen fuel cell buses, as well as building a fueling infrastructure at one of our bus yards. We felt that, with our experience with battery electric buses, doing a pilot of 3 or 4 or 5 buses doesn't really give you a full experience, as opposed to having a larger amount of fleet to pilot that technology. And so far, we've been successful in terms of implementing that project. The buses operate like you're operating your fleet with CNG buses, quick fueling. The only issue now is the cost of hydrogen fuel. Costs us about close to 3 times as much as we pay for a compressed natural gas bus.
So one of the interesting thing that comes up, when I studied mechanical engineering, right? I mean, we studied ICEs. So we've had like 100 years to standardize on internal combustion engines. And in less than a decade, right, agencies are being asked to operate, with new technology, and in fact, with new technologies side by side. And that's kind of an unprecedented shift. And as you pointed out, there's a lot of learning happening on the job, so to speak, as you run these pilots. So right now, your team is maintaining, so this is sort of the dual fleet reality, right? I mean, your team is maintaining CNG buses alongside with zero emission vehicles or other technologies, and each with fundamentally different service philosophies, different parts, different inspection protocols. what does a normal day look like? When you look at this as a maintenance practitioner, where does the
Yeah,
complexity actually show up?
yeah, interesting question again, Satish. Yeah, you're hitting the right spots here. So when we buy buses, we always include training modules into the contract. We did that with battery electric. There was a lot of focus initially on the safety and safety elements of a battery electric bus because of the high voltage systems in there. A lot of learning in terms of battery management software, learning about electrical elements of the bus. What's interesting is what I've realized with zero emission, with battery electric or hydrogen fuel cell, there still is a portion of the technology that you can't really hand over to your mechanics. Um, Hydrogen fuel cell, we did the same thing as well. We invested of $180,000 for training modules for our technicians in terms of learning, doing diagnostics, repairing hydrogen fuel cell buses. In addition to that, there's a list of tools now that you need that you don't really use with internal combustion engine buses. So there's an investment in training. There's another investment in tools, safety equipment. So what we did was we had selected specific technicians that we purposely trained just for the zero emissions, because you can't everybody train for zero emissions because you still have the internal combustion engines. So we selected a specific number of mechanics to be trained to understand, how a fuel cell stack system works, the battery itself, the components, the tools that you need, the diagnostics. What I've learned with zero emissions, there's always a part of diagnostics that needs to be handed over to the engineers of the technology manufacturers. Our technicians would diagnose and they would say, this is what we found out. Here's the issue. I think we need to replace the compressor, or there's a degradation of the fuel cell stack system. I think there's a little bit of moisture within the fuel cell stack. How do we dry that out? So they send that information to the manufacturers of the equipment, and the engineers would have to diagnose, review, and sometimes it takes them weeks to respond, and then they'll tell us what needs to be done. So, as opposed to internal combustion engine, once you have technicians that are trained, the handout is direct.
Sure.
Right? Yeah. Here, you have your tools. Here's the bus. They know how to rebuild the engine. They know how to replace pistons, change the oil or whatnot. But with zero emissions technology, there's no complete handout, and I don't know when that happens because there's so much software and involving programs and whatnot that our technicians can't do, and there's that proprietary concept as well. So.
Yeah, and I guess this sort of goes back to the fact that, like I said, between 115 to 140 years of sort of knowledge about how internal combustion engines work, and there's a lot of institutional knowledge that is already captured. And this is sort of new and emerging technology, and all of these technologies, they move fast. Some of them work, some of them don't. I think there's a lot of learning involved here. But one of the other things I did want to talk about is also, there is the compliance burden, right? Safety standards, regulatory reporting, inspection cycles. How do you maintain that accountability across two fleets that don't share the same rule book, for example? I mean, what are the blind spots that you worry about the most?
Interesting. So with battery electric, there wasn't much of an issue in terms of modifying our facilities. With hydrogen fuel cell, it's a different technology because you're involved with working with a volatile gas that doesn't have any color, doesn't have any odor, and you can't see it. So we had to invest over $1 million at our Pomona yard in terms of upgrading gas detection systems. We had to enlarge the um, exhaust fans that's in the facility. This was all determined by a engineering consulting firm that had to look at the facility and perform analysis in terms of air movements within the maintenance building itself. So we had to meet the requirements in terms of upgrading the facility so we can pull a bus and perform maintenance within the bus facility itself. Without that, we wouldn't have been able to, we would have to perform repairs and maintenance outside of the building in open air. Even the solar heaters, we had to reduce the amount of heat that's generated by the solar heaters because in case there's a leak from a hydrogen leak from one of the buses, if it generated too much heat, you can ignite the gas. So there was a lot of changes that had to be put into place. Also, having the proper PPEs that the mechanics had to utilize in order to perform repairs to avoid electrocution or yeah.
Sure. Yeah. So this sort of segues into the next part of what I wanted to touch about, right? One of the real challenges isn't just the compliance; it is compliance across two different operating models.
Mm-hmm.
And without a digital system, and this is where I guess Connixt came in here, but it generally becomes extremely hard, and this goes right into the technology and the people. At some point, you decided to start a digitization initiative to manage all of this, and I'm glad we were able to support this with the Connixt iMark suite. If you can walk a little bit through that decision, what was sort of the inflection point where it was clear to you that a platform would be needed to build this kind of complexity rather than simply trying to stretch existing tools to fit your needs?
Yeah. So, for years, I've always wondered, like, why are we doing this paper work orders at our facilities? We're moving, to a new technology in terms of our bus propulsion system. We need to be able to record the preventive maintenance because there's different preventive maintenance requirements versus an internal combustion engine, a battery electric bus, even a hydrogen fuel cell bus. And a lot of those things were kind of hard to capture, having a paper routine of doing your work orders, recording them, and being able to capture those instantaneously. So, and effectively having to delay the process of recording them in our CMMS. So I started looking for a paperless process, and luckily I ran into you in one of the conferences and inquired about Connixt. I think you did a presentation as well.
Yes.
Way back, I think it was a CTA conference in Long Beach.
Yep.
So I was like, hey, I find this very interesting. So we did a conversation. We had a meeting with you, and you provided us a presentation of your product. The paperless system, we've got tablets now that our technicians use to record diagnostics and repairs that they're performing. It's all being recorded instantaneously and back-fed into our CMMS, which is RTA. Also, in addition to that, there's a lot of upgrades that your system provides. For example, our technicians, some of them are bilingual, and some of them are kind of shy in typing out reports in detail. So one of the upgrades that we're looking forward to is the ability to be able to speak to the tablet and have that translated into a written information on the work order itself, which is really helpful in terms of that approach. In addition, being able to speak in your more common language into the system and translate it to English, that's fantastic. That's wonderful. As well as having the ability to take pictures or take videos of issues that the technicians find in the buses. These are all improvements. It's going to make the whole system work efficiently, effectively, and make it a lot easier for our technicians in terms of recording repairs and performing the repairs. In addition, we've also put in the PMI schedules into the system itself, so all they have to do is to pull out whatever PMI schedule they're working on and automatically loads it up into the system. So it's a great system that we've been involved in and helping us perform repairs and maintenance on our different technologies that we have.
Yeah, thanks for that, Roland. And again, this is something that we have done our best to meet, sort of on every single day basis, which is to make life easier for the mechanic or the technician, because ultimately the point of failure is right there on the field. So, and again, Foothill has been a great partner in that. And that presentation years ago, I think was at a CTA in Long Beach, and I think we were presenting how Los Angeles Metro had been using our product back then. So again, and we've come a long way since then too. It sort of leads me to the other thing. One of the earliest conversations we ever had, Roland, was about visibility. Your ability as the person in charge to know what's happening across the fleet from a maintenance standpoint at any given moment. What does that look like now compared to before? What impact are you seeing of that? And what is it you can see today that you couldn't see before?
There's a lot of things that have improved. First off, the instantaneous recording of the work orders getting fed into our CMMS RTA pulls it out automatically, as well as being able to see more of the detailed analysis and diagnosis. We're still trying to assist our technicians to be a little bit more detailed in terms of what they're entering into Connixt, but I think in terms of the preventive maintenance that we've built into the system, it's made it a lot easier for them to perform the PMIs as well as the schedule being built in. It's been a little more efficient in terms of how those things are being created. We're not losing any records as opposed to having a paper trail.
So in fact, one of the things we see, we also observe this in some of the other industries we operate in, trucking and railroad, for example, right? The story is kind of the same. We're not replacing one fleet with another. We're layering new technologies onto existing operations. And that gives rise to complexities in terms of, different technologies, different reporting cycles, and so on. This sort of leads us to kind of the sort of the last portion of what we wanted to talk about here. And again, if there's more questions, please do pop them into the chat. This is just for everybody listening in. The hydrogen infrastructure build out, right? The fueling stations, the dispensing systems is a massive capital and operational undertaking on top of the maintenance transition. How do you think about sort of managing this complexity alongside the fleet complexity? And does your maintenance platform touch that layer at all? I mean, it's basically, there's a lot going on. There is the capital spend, and then there is the operational challenges.
Yeah, this whole zero emissions transition program is not easy. Been doing this for 15 years. And I always tell everybody the easiest part is buying the bus. You go buy the bus, they'll build it for you. You got the money to pay for it, and they'll deliver it. The whole issue is in terms of whether it's battery electric or hydrogen fuel cell is, first off, the infrastructure. It costs a lot of money to build these charging stations. Our hydrogen fuel cell infrastructure, we started construction back in 2021. Back then, the price for our infrastructure is about $7 million. I think we got a good price for it, because right now I've seen, proposals for those builds at around $12 million. So in the last 5 years, they've almost doubled up. Um, we're not I don't have teams that are engineers in the cryogenic world. So in terms of maintenance, whoever designed built it, we contract with them for the maintenance of those facilities. And that's pretty costly too. That's about $180,000 a year in terms of maintenance of the facilities. And that's during the early years. So as the equipment gets older, I would assume that the cost of operating and maintaining that equipment is gonna increase. Um, hydrogen fuel cell, again, we're lucky at Foothill Transit to be able to acquire a cost of $9.70 for per kilogram of hydrogen. I know there are other organizations out there that are paying much higher, in the $30. It's very costly, to transition to zero emissions. Not only just maintenance, capital investments, price of the bus. Yeah.
If you sort of had to go back to the moment that the first zero emission vehicles rolled into your yard, what's the one thing you would have had figured out on the maintenance and the tech side before that bus arrived? I mean, sort of looking back, what is it that you might have wanted to figure out, right at the outset?
What I wanted to know how reliable these buses were in the beginning. I think we delved into the zero emissions early on, not really fully understanding how it fits into transit applications. Does the battery, right now, my experience with battery electric and hydrogen fuel cell, the hydrogen fuel cell buses still have batteries in them. And we constantly experience these battery string failures due to heat. I wish we would have understand that battery vehicles, especially cars, there's a different application, there's a different use to it. It's not heavy use. You drive your car in the morning to the office, you plug it in, you charge it for 8 hours, and then after work, you go home and drive another 35, 40 miles, you go home and plug it in. Well, with buses, it's a different application. It's constantly running into service, 9 hours, 10 hours, 8 hours, 5 hours, stop and go traffic. I think with that heavy use, it has a heavy impact on batteries. I wish we would have known that earlier. In terms of battery use, why can't we just use hydrogen fuel cell to create electricity and power the propulsion system directly instead of having batteries in them? A lot of learning in terms of the price of the bus as well. I think initially, we knew they were going to cost a lot of money because of, somebody's got to come up with a reimbursement on research and development. But, we were told that in the future, the cost of zero emissions vehicles were going to be comparable to a compressed natural gas bus. I wish we would have known that it wasn't, so we would have taken the time to transition. We're still in the same boat as we were, I think, when we started. We keep on doing the same thing over and over again. I think there should be more innovation being taken as part of government funding some innovation, research and development in terms of prior to implementing some regulation to transition to zero emissions.
So this kind of brings us to my last question here, Roland. So for the transit agency leaders or the fleet owners in the private sector that are watching today and who are still about 12, 24 months away from their first zero emission procurement, what's the conversation they need to be having now internally? And you've touched upon a couple of these things, but if you had to pick just one or two of these things, what is the conversation they need to now have internally, and what should they be demanding from their maintenance technology before the bus arrives? Anything forward-looking, practical advice that you can point to?
I think first off, is it is this technology really applicable to your service or your transit system? Can you delay it a little bit further as we see more improvements? I've heard that there are research in development in terms of, testing a internal combustion engine powered with a hydrogen gas instead of using compressed natural gas bus. I think that approach would lower the cost of the bus because you don't have batteries, you don't have fuel cell stack systems. I think just understanding where the technology is moving, and look at your team, your technicians. Do they have the basic understanding of, electric power, a little bit of chemistry? I think what you need to do is, as part of your workforce development, you're transitioning to zero emissions. As part of your workforce development, I think doing an assessment of your maintenance crew, assess what their capabilities are, what is their understanding of the electrical systems or electricity itself, chemistry of hydrogen itself, if you're looking at hydrogen fuel cell, and understanding where their level is so that you can assist them developing their skills before you institute the transition to zero emissions. It'll be a lot easier for them because you're increasing their knowledge prior to the implementation of a new technology. And that's one thing that I think we kind of lacked in the beginning as part of our workforce development, and doing an assessment, I think, is a very important part, an initial part of introducing your team to a new technology.
I mean, this sort of summarizes what I think something we touched upon earlier. As you pointed out, the easiest part of this is buying the buses because you have the money, you can buy the fleet. I think it is the people, the process, and the technology. I think that always sort of each of these is a point of failure potentially, but also one of the levers for success as we go forward. Because the better trained the crew is, then everything else sort of falls into place. Well, that sort of ends the set of questions I had, Roland. I honestly, I think we covered more than we planned to, but I truly appreciate the time you've taken today. And I'm sure that, typically we have questions that also follow through afterward. And if they do come in, I will, sort of pass them on to you, and then we can respond directly to those that ask the questions. But otherwise, I truly, honestly, thank you for taking the time today. I know you're in the midst of some very busy things going on, this time of the year, and with your new fiscal and everything else. So thank you for that.
You're welcome. Thank you for inviting me. Thank you. I hope I was able to provide some answers to the questions that relate to whatever things that people are working on right now, and help them out in their daily operations.
Thank you again, Roland. Want to thank everybody for attending, and we'll look forward to reconnecting sometime soon. Thank you.
Great. Thank you. Appreciate it.